In this problem, two blocks A and B whose weights are given as WA, that is weight of block A is equal to 500 Newton and weight of block B is equal to 1000 Newton. These two blocks are placed on an inclined plane which is at an angle of theta with the horizontal, as you can see in the figure. Also, these two blocks are connected to each other using a light inextensible string. The coefficient of friction between block A and the plane is given as 0.15, and that between block B and the floor or the plane is given as 0.4. We need to find the inclination of the plane with the horizontal, that is the value of theta, and also as we know, when these blocks tend to move, there will be some tension will be developed in the string which is connecting the two blocks. So the tension T also we need to find out. So we need to find the inclination of this plane with the horizontal, that is theta, and the tension T in the string. To solve this, what we can do is we will resolve the forces acting on the body in two mutually perpendicular directions. That is, one direction will be parallel to the plane and the other will be perpendicular to the plane. That is 90° to the plane. So in this, instead of x and y directions, we will resolve the forces acting on each bodies in two mutually perpendicular directions. One is parallel to the plane, another is perpendicular to the plane. Okay, we have already told that if a T is the tension, we need to find the value of magnitude of tension and as well as value of theta. Now, for block A, if we draw the free body diagram, it will be like this. This is theta, and the weight will be acting through the center of gravity in the vertically downward direction, like this, that is 500 Newton. The reaction will be perpendicular to the plane. Perpendicular to the plane. This will be RA. Okay. Then the string will be trying to pull the body up T. And as the body will have a tendency to move down, the frictional force will be acting in parallel to the plane in the upward direction. Up the plane like this. So this is mu A into RA. Mu A into RA. So these are the forces acting on the block A. Then what will be block B? The forces acting on block B on the same plane, inclined at theta, and this will be block B. Block B will also be will have a tendency to move down. Therefore, the frictional force will be in this direction, and this will be the reaction RB, and the weight will be acting vertically downwards like this, 1000 Newton, and this will be mu B into RB, and there will be tension T in this direction. I'll draw it here so that it will be more clear. Same plane, block B, its weight is acting vertically downwards. Normal reaction at the contact surface RB. As the body is having the tendency to move down the plane, this will be mu B into RB in the upward direction, opposite to that of tendency of motion, and this will be the tension, and the angle of the plane is theta with the horizontal. So these are the forces acting on block B. This is block B, this is block A. Now I have already told that we will resolve the forces or consider the forces parallel to the plane and perpendicular to the plane. Now parallel to the plane, the forces are mu A into Ra and T. There is one more force which is the horizontal component of weight of the block, because the weight of the block is acting at an angle with the plane, say like this. There is an angle between this plane. So weight of the block, as it is acting in the vertical direction and the plane is or the block is placed at an inclination to the horizontal, we need to consider this 500 Newton, that is the weight of the block, is to be resolved into two components. It will be like this. Weight is acting vertically downwards like this, therefore it should be resolved into two components like this. Along the plane, along the plane, and perpendicular to the plane like this. Okay, so from the figure geometry, it can be seen that this angle is theta, same as this angle. So this component will be 500 sin theta, and this component will be 500 cos theta. This will be the weight. So we can say the block B is having the tendency to move down the plane under the action of 500 sin theta, and the force of friction, that is mu A into Ra, with the T, will be acting in the upward direction, that is opposing the motion or opposing 500 sin theta. Similarly for block B also, the force of or the weight is acting in this direction, so it will have two components, one in the perpendicular direction to the plane, that is 1000 cos theta, this will be 1000 sin theta. So these are the components of forces acting on block A and block B. Other forces we need not resolve because it is already in the mutually perpendicular direction, that is parallel to the plane and perpendicular to the plane. Okay, now we will apply equilibrium equation in two mutually perpendicular directions, that is equilibrium of forces along the plane for block A. Let us consider block A first. So parallel to the plane, if we consider the forces and equate it into 0. because these two bodies are not moving now, they are just to move. In the next moment they will be moving. That means they are in equilibrium now. There is no motion. Therefore, we can say the sum of forces or algebraic sum of forces parallel to the plane on block A equal to 0. That is, which are the forces parallel to the plane on block A? First force upward direction mu into Ra, second is T, and in the downward direction it is 500 sine theta. Therefore, we can write T minus T plus mu A into Ra, because these two are in the upward direction, so both are positive, minus 500 sine theta equal to 0. T minus 500 sine theta plus mu A into Ra, or T plus mu A into Ra minus 500 sine theta equal to 0. When we substitute the values, we will get T plus 0.15 Ra minus 500 sine theta equal to 0. We don't know the value of theta, so we'll put it as such. Then, if we consider the forces perpendicular to the plane, for block A, what are the forces perpendicular to the plane? That is Ra and 500 cos theta. Ra and 500 cos theta. So it will be Ra equal to 500 cos theta. How you will get it? Because 500 cos theta is acting downwards and Ra is acting upwards. Therefore, Ra minus 500 cos theta equal to 0. There is no vertical motion in the perpendicular direction. Therefore, Ra minus 500 equal to 0, or this will give Ra equal to 500 cos theta. Ra equal to 500 cos theta. Therefore, this equation, let this be equation number 1. Equation number 1 gives, how we will get it? T plus 0.15 into 500 cos theta minus 500 sine theta equal to 0. Okay. How we got it? We substitute the value of Ra as 500 cos theta in this equation, equation number 1. Equation number 1. So it will be T is equal to, this will give T is equal to, we take these two terms to the right side, that is 500 sine theta minus 75 cos theta. That will be the equation for T. So once we get the value of theta, we can easily find out T. Now if you consider the block B and resolve the forces in parallel and perpendicular directions of the plane, the inclined plane, it will be, so for block B, this is block A, and for block B, if you consider the vertical forces, equilibrium of vertical forces, then that should be equal to 0 because there is no motion in the perpendicular direction. RB should be equal to 1000 cos theta. RB and 1000 cos theta must be equal to 0. 1000 cos theta is the perpendicular component of 1000 Newton, which is perpendicular to this inclined plane. So it is RB equal to 1000 cos theta. Therefore, mu RB, or the frictional force, say FB, equal to 0.4. It is the coefficient of friction, mu B into 1000 cos theta. Mu B into 1000 cos theta. Or this can be written as FB equal to 400 cos theta. FB equal to 400 cos theta. Then, when we consider the forces parallel to the plane, the components and the forces acting in the parallel direction is parallel to the plane is mu B into RB, that is FB, that is equal to 400 cos theta is in the upward direction, then minus T in the downward direction, minus 1000 sin theta, that also in the downward direction, and this should be equal to 0 because under the action of these forces the body is now in equilibrium. The next moment it may move. So 400 cos theta minus T minus 1000 sin theta equal to 0 because 400 cos theta is the frictional force we have calculated here. It is acting in the upward direction along the plane, parallel to the plane, and T is in the downward direction, and 1000 sin theta is in the downward direction. So we have two equations in T and theta. We have two equations in T and theta. Now when you solve this, we will get theta equal to, we solve these two equations, say equation 2 and equation 3. We have two equations in T is one unknown, theta is the other unknown. Only two unknowns are there. If we have two equations, we can solve it. So when we solve this, we will get theta is equal to 17.59 degrees. And in either of these equations, if we substitute the value of theta, we will get T equal to 79.61 Newton. So these are the answers. Inclination to the plane is theta is 17.59 and the tension in the string T is equal to 79.61 Newton.